All right, happy National Chocolate Covered Nuts Day. There was like one, I think this was the only one to choose from today, if memory serves me correct. So that's what today is. Just a reminder that next week, Tuesday, is going to be your test, and that will encompass vectors and navigation. Today we're going to wrap up our notes with vectors and navigation, and then tomorrow you'll have a quick solve to do in class, and then Friday will be a review day for 2 mods on Friday, so Friday will be a review type day for that one. Maybe we'll do an example, maybe we won't, depends on how we feel that particular day. Okay? And then Pi Day extra credit is coming up. Less than a month, actually, 2 weeks, 3 weeks, 2.5, somewhere in that range. Okay. All right. So to start us out today, let's go with this as a warm up for you. Find me given vector the parts of vector V and the parts of vector W. Find me those 4 different things. All right, so vector V would be 20 cosine of 170 degrees, 20 sine of 170 degrees. And that would be then approximately 20 cosine of 170 negative 19.6962 3.4729.6. And vector W would be 55 which would be 40, 22. And negative 37. So 2V minus W then would be me and my calculator, I would go 2A minus H negative 79.617. And 2B minus I, 44.456. Agree with me on 2V minus W. No objections. That sounds like it's good. V plus W then would be 20.528. And negative 34.037. Okay. Magnitude of that then would be that. So the magnitude of V plus W would be 39.748. No units on that one. Direction angle of V plus W, I'm not in quadrant 1, so I'm going to have to use a reference angle. So that's going to be the inverse tangent of 34.037 over 20.528. On my calculator, because the vertical component of V plus W was negative, I'm going to go inverse tangent of negative Y divided by X. That gives me 58.9051. This vector is a quadrant 4 vector. So that means my actual direction angle is going to be 360 degrees minus my reference angle. So my direction angle of V plus W then would be 360 minus that, 301. Questions on those four? Okay. Let's talk a little bit about Quentin. I do have to say, though, that this should be country, not city. While vacationing in Italy, a man named Quentin whisks you away in a beautiful yacht to the city of Palermo in the country of Sicily. While aboard, you meet the sweet captain named Tommaso, who, while he doesn't speak any English, shows you the gauges that indicate the true bearing and speed of the ship is 27 knots at south 42 degrees west. The wind is from the southeast and blowing at 3.5 knots. And the current is pushing the boat at an angle of north 18 degrees east at a speed of 4.3 knots. Okay. What is the actual direction the bow of the ship is pointed? And what is the actual speed of the engines could achieve in still water and still air? So if it was in a bathtub, what was the actual speed? Okay. Lots of stuff going on here. Okay. Let's break it down. And then we'll get it set up, and then I'll have you guys actually calculate it. Okay. So let's talk this one right here. True bearing and speed of the ship is 27 knots. In our A plus W equals G, which one is that? A, W, or G? Because it used the word true, it's G. Yep. Because it used the word true right here, words are going to matter in this problem. Hint, hint. That means that this then is G. Okay? Included with that. Okay? The wind is from the southeast and blowing at 3.5 knots. Is that A or W? It's going to be W. Okay? The current is pushing the boat at an angle of north 18 degrees east and 4.3 knots. What's that one? That is not A. It's another W, right? Okay? So let's call this one C just to keep them separate. Okay? So that one would be C. Okay? And we're trying to find the actual, right? So we're trying to find A. Okay? So in this particular case, it would be A plus W plus C is equal to my G. Agree with that? Which means if we're trying to find A, then A would be G minus W minus C. Yes? Now I will tell you that there is one word that you need to make sure you understand going into this problem. What is the most important word in all of that? From. This word right here. If it's from the southeast, that means it's actually going which direction? Northwest. Okay? If it's from the southeast, that means it's actually going northwest. Okay? You now have enough information to do that problem? Do it. All right, let's talk G first. So G has a speed of 27 knots, south 42 degrees west. So that would be down here where this angle is 42 degrees there. I need to know this trig angle here. 270 minus 42 is 228 degrees. So G would be the vector 27 cosine of 228 degrees, 27 sine of 228 degrees. We can just calculate those right off the start. (27) cosine 228 that one, and 27 sine 228 is being that one. Okay. So that gives me negative 18.0665 and negative 20.0649. Okay. So that's G. Now let's do W. Wind is from the southeast. So the southeast would be there, which means it is blowing northwest. Oops. Which means it is blowing northwest, which means that my trig angle then would be 135 degrees. So W would be 3.5 cosine of 135 degrees, 3.5 sine of 135 degrees. So that is negative 2.47487 and 2.47487. Okay. Then we've got the current. The current is flowing at north 18 degrees east. So this angle in here is 18, which means my trig angle here, oops, excuse me, would be 72. So my current then is 4.3 cosine of 72, 4.3 sine of 72. .32877, 4.08954. Okay. So A is going to be G minus W minus C. So my vector A then is going to be blue minus green minus red. So that's going to be A minus H minus O on my calculator. And I'm going to store that as X, negative 16.9204. And B minus I minus P, I'm going to store as Y, negative 26.6293. So that is my vector A now. Vector A is what I am going to use now to find the magnitude of A. that is going to be the ship's speed. It could be GCW too. But G's got to go first because of how we set it up. Because of this. Because what we point the ship at, what we set the ship at, then gets acted upon by the wind, then gets acted upon by the current. Okay? So if I have these three here, then I got to subtract them. And it's got to be in that order. So then this is the which is going to be 55,031. Okay. I need a reference angle. Because they're both negative, I don't have to worry about dropping a negative. I can just go y divided by x. Gives me 57.5679. Okay. Now, this angle, so this vector is going this way, and the angle that we just found was right there. I need to have this angle in here, so that angle is going to be 90 minus my reference angle. So 90 minus my reference angle is 32.4321. Make sure we've got 43211. Okay. Oops. So the ship is actually doing 31.550 knots at a bearing of south 32.432 degrees west. Or is what the captain, Tommaso, has it set at. It all depends on where it is. You got to kind of figure out what, because like this one, the angles were given to us in this format, the north-south angle, east-west format. So that's why I needed to. If it had been, it was given to us in bearing angles, like full-on angles, then in this particular case, I would have done 270 minus my reference angle.
Oh, so it's just...
Yep, it's just converting it out of trig back into navigation. Try that one.